Right, so that completed box 40 belonging to Richard. Next we're going to be doing the box of 6 belonging to Julian. We're going to start on that. But, as I said, we're going to do one of our jobs, a customer job, one of our jobs, a customer job, and so on. So we're going to move on to box 32, which is something our mystery benefactor Alan has sent on to us once again. And he sent a little note with it. And it's a Kernow Beta 1100. So it's like the Midland 095, but these work well. Whereas the squelch is a bit iffy on the 095. Another radio for you. I know you like this model. Works well, needs a tune-up. Mic works, needs a plug. I cut it off. Oh, he needs a plug. Right. Is that a sensible modification to alter the audio bandwidth? Well, find out, won't we? So, I'm going to open it up because I'm intrigued to see if I can see anything obvious that's happened to this. And it's a 4-pin plug we want. Right, that's easily sorted. Where's my screwdriver? I don't recall these even suffer from the dry joints that the Midlands suffered from at this era. Another example of cheaper was better. Right. So is this the modification going around the... you just wouldn't use a Hunt's capacitor. These are capacitors that have really failed. So it's 0.01 between that point and Earth. Now these capacitors really suffer from being leaky. So it may be 400 volt rated at one time, but we have got a Heathkit tester for leakage. It's not available here at the present, but we have got one. The first thing to do with this is to wire a mic up. What we'll do is start by putting this on the clipboard. Kernow Beta 1100. Oh 25200. Can't even read that. 0688, made in China. Box 30, I've already forgotten 32, wasn't it? Yeah. Right, so we'll do that first. Right, so we've done a plug. Use Mr. Chippy's little heat gun, if I can read what the settings are on the back. Very useful, something that's battery operated. Good. It's the teeny weeny screw. Knights at Curtin and Lindsay sell these. Right, see whether that works. It does. Let's go through the figures. So, transmit power, we're on channel 20. It's 2.75. 2.75 watts. Channel 40. 2.8 watts. Channel 1, 2.72. Back to channel 20. Now these have PA, I don't think they have low power, do they? So although it's 2781, or is it 2781? No, it's PR2794. So, no low power. Transmit current is 834 milliamps. And as the radio comes in, it's wall at 1.5 kilohertz. Frequency. The test set's been on for about 3 hours. So it's slightly low, 27,79087. Starting to notice it would be low at that. You know what? This has been overvolted. There's 3 distressed capacitors there. Right, TC1. Oh, 27,792 with 1 turn. Receive. So we'll put the true frequency in of 27,79125. Not having to adjust it for being off frequency. we need to plug the extension speaker in, and while we're at it we'll plug the PA speaker in, because these have public address. Testing 1 2, testing 1 2 3, 1 2 3 4 5 5 4 3 2 1 1 2 1 2. So that works. A bit bassy. That works. No meter. And the sockets work. Back to CB. Switch the cyanide meter on and let's go over to that. So right now it is 0.76. I'll show you the attenuator rather than the cyanide meter. That's 10, 0.58, and if it will do 20, it will do it at 2.27. Squelch tight. Microvolts, just where it should be, or in my opinion where it should be. And squelch threshold, signal generator to standby, squelch set, .32. Absolutely, that is absolutely as you want it. Switches are fine. I'm not sure about the potentiometers yet. I'm also not that sure about the VCO. It hasn't been fiddled with. We'll come back to why that's loose when we've tuned it out. Also need to discover what that's doing. It looks like it's on the volume control. So, an added tone control. Actually, let's go back to PA. I need to wait for soldering out, so we'll come back to that in a moment. Right, so we'll go up the transmit side of things. I've already printed out. Is that the right one? Yeah. Right. Unplug the test equipment speaker. So see if we can advance from 2.8 watts. That's already perfect. I wanted a little tweak. That was perfect. Little tweak. And that should be the power preset. Just go over to there, change, see what we can. And with it at 4 watts, I'll just go through these final ones again. I suspect that's the 54 meg trap. Just knock that down an absolute fraction. There we go, 4 watts. Let's change channels. Channel 1, 4 watts. channel 40, 4.05. And the transmit current when we go back to channel 20 is 1.015. Right, so we'll do the deviation. Which is there. Wallow. I don't know whether this is playing up like it did a couple of weeks ago. Wallow. I'll check that with another meter. So, soldering iron's warmed up. What I want to do is this. Let's try and listen to PA. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 1, 2. And then remove this. Oh no, I want to listen. Yeah, we know what it sounds like. Let's turn the set off a moment. Testing 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2. Testing 1, 2. So we've got more treble there. So whilst this is on, let's just put that on there. 1, 2, 1, 2, 1, 2, 1, 2. So it's dropping the treble off dramatically on the received audio, and that's going to affect the synad. So we'll go back to CB. And plug the extension speaker back in. Into the test set. So we've got, let's go for 12 dB, which is now 1 microvolt. Put that on. It does improve because it's dropping the treble off. So these are really troublesome capacitors. So if you ever see something like this in your valve radio, it needs changing. This one's cracked. By the looks of it, I'm sure it's not moulded like that. So although it may still be working at this voltage, this isn't a suitable meter for this. But I'll just out of interest. Yeah. Let's go for the correct meter. So it isn't the capacity it says it is. This says 0.05, which is, so let's get this into perspective. Yeah, it's 75. It's actually high. Should be 50. Right, the next thing to do is to find out why this is all loose. we also need to change those 3 capacitors, which, if there is some tonal problem, is why. So I'll just pop that mic off. And pull the knobs off. What's actually happened? I think the front's actually broken, hasn't it? Yeah, I think the front's broken. We may be able to glue that, or I'll have a look if I've got a front off a scrapper. We bought some fronts off eBay, and I was disappointed because half of them weren't for UK sets, so they just ended up in the bin. And the answer is no, we haven't got a front. I'll tell you what is in that box. That's a Major 3000 front, and that's sad. And a Radiomobile 202. Who's chopped up one of those? Somebody who didn't pay $119.99 for it on day one. What? It'll be the glue. Okay, so a couple of hours later, we've now done the capacitors. One of them I took out was faulty. So I took these 3 out, clearly distressed, overvolted, overheated, whatever. And one of them, not the worst looking one, 47 microfarad one, read it read very leaky. So that's going to have changed something, but I can't say I'm looking at the circuit at this stage. So let's see what we can do with the tuning of the receiver. So this is all being glued, and I took the front panel off, and the 2 plastic inserts had sheared off, and I've managed to get the hot glue in there. At the same time, what else was I doing? I've forgotten. No, I think it was just gluing those and putting it back together and doing the capacitors. Yeah. So detector, let's have a look at that. So S9 signal on the test gear. Is picture in picture actually showing? Well, it's on now, if it wasn't before. So let's have a look at the oscilloscope. It's a bit more volume, so I get a better trace. And the detector coil is there. It's a little tiny better bit there. Right, over to the cyanide meter. Let's see what we can do. It's about 4 dB on there. Absolutely spot on. That's absolutely spot on. That might be better with the bigger signal. No, nothing's made any difference. Well, that looks pretty central where it is. Now, bearing in mind we've taken that capacitor out, which has made a tonal difference, this figure will be worse, but the set won't be less sensitive. So we now have 0.92. And we now have 0.74. And 20 is now 2.7. 2.27. No. 2.7. So, if we now put this back to 12 dB, see, you know when we're doing sets with a bit of a tone control switch, like the, I think the York 863 has a tone switch in 3 positions, 1 or 2 sets, I think those major 3000s do. We always do the synad on the low position, and we usually use the set in high position. So this is what this capacitor is doing. If I just put that across where it came from, probably better to there. You see how that's improving the signal. Now, if I can, I'll tell you what, I'll just solder that back on for a moment. I'll solder one end on. And just physically hold it on. Now, let's look at where we are now with the synad. So we're comparing like for like. I've now got 0.72 microvolts, and so you'll see we had 0.76 before. So we actually have improved the synad slightly, but that's not the way to do it, and I don't want to introduce a tone thing on a set that's not supposed to have a tone control. So as I said before, that is cracked, and that's typical of these. They crack over the years, they get moisture inside. It's a paper type capacitor, and it might work at this kind of voltage, but for the originally intended application at line valve radios, that would be short circuit. Good. I was going to say we've got the S meter to do, but we haven't got the S meter to do. Let's see where we are with the squelch now. So I'll turn the squelch to full. Microvolts. Yep, it's still 100 microvolts. But sometimes doing a retune alters that. So at the sensitive end of the squelch, got 0.85. Got reasonable hysteresis. Good. Just only thing is the deviation, whether the meter's not reading right on this test set, which it seems to do from time to time. Just take the extension speaker out. Wallow. I'm going to have to test this on a secondary meter. Tell you what we'll do. We'll plug my walkie-talkie into the deviation meter. Let's go back to that camera. Wallow, wallow, wallow. Wallow. It's reading 2, which is about where they are. So it may not be playing up. Maybe this radio's low. See, once you've had something play up, you start to not trust it. So I can usually tell. Testing 1 2, testing 1 2 3 4 5. Wallow. 1 2 1 2. Wallow, wallow. Well, according to that, it's peaking at 2. So that may be how it is. At the end of the day, it's our set. So I'm going to say it's 1.8 to 2 kilohertz. Good. Right, just recheck power, make sure we're not stupidly over the top. Spot on the 4 watts. Brilliant. So I'm going to pause the video, and I'm going to look at what that capacitor did that was playing up. Right, I've just looked up those capacitors, and the 2 which didn't read as being faulty but still looked distressed are in the mic preamp, and the one that was reading faulty and was very distressed was actually in the 6.2 volt regulator rail to the phase lock loop chip. So I'm really glad I caught that, because you don't want things like that to play up and end up with the wrong voltage being applied to the phase lock loop. So good. I just want to check it on channel 40. Yep. Channel 1. Yep. Good. Right, so that's it. We put it back together. So a lot of fiddling about with that, and you've not got much room when you take the front panel off, because you've got all the connections to the microphone. Right, I'll switch the test set off. Switch picture in picture off. And we'll put the aerial in. I'm just waiting for the soldering iron to warm back up. I know these videos are probably 40 minutes, but they can be done over the course of a whole day when I've got 20 minutes here and 20 minutes there. So it's now just gone 5 o'clock. I started this about 11 o'clock this morning. got all but 2 rollers in on these pedal roller board on the organ, so I've every intention of putting all the rollers in, because when my help comes tomorrow, I think it's Simon tomorrow, we want to be fitting the roller board to the organ, not connecting it to anything. That's something I can do very slowly, wearing my knees out. But I want to get on with the pedal board, and then that's everything that needs a bench done. So I really want to get the building in operation and not looking like a workshop. Right, I'll tell you what, while I put the screws in, we'll park it on channel 19 and see if any bad buddies come through. There we go, all put back together. One Anna Roger. Happened again, hasn't it? It's just gone 5 o'clock. There's nobody on. I'm sure they'll all get called in for their tea. Oh dear. Right, so I'm very pleased with that result, and thanks very much, Alan, for sending that in. That's really kind of you, especially to get the mic as well. The original Kernow Electret mic. I think it's an I tell you what, we've never opened one of these up. It feels light enough to be Electret, but I might be wrong. Yeah, it is, isn't it? Yeah, there's the little Electret capsule down there. I'm sure they're cheaper in recent years, and it's got a added weight in it, which is what we found with the Maxon business radios, to give it a nice feel. to listen to it on our testing 1 2, testing 1 2 3 4 5. That sounds absolutely fine. Good. Right, the on the air test will follow later today. Thanks for watching.